Hi, this is Martha Moody. We are on week 2, part 2, page 15. When I left off in the last video, I'd asked you to go ahead and try to work these 5 problems using the FOIL method. So if you have gone ahead and done those, you can go ahead and check your answers there at the bottom of the page, or if you want to pause the video right now and try them, you can certainly do so. So if you want and have not completed these already, go ahead and pause it and then check your answers. So the answers to these problems are x plus 3 times x plus 1. We have 2 terms times 2 terms, so we can use the FOIL method. The first term times the first term is x squared. The outer 2 terms are the 2 that are the farthest apart, so we have 1x. The 2 terms that are the closest together are this 3 and x, so that's a positive 3x. And then the last term in this first group is 3. The last term in the second group is a 1, so 3 times 1 gives us a 3. And then what's typical, we can take the inner term and the outer term, and because they are alike, we can add those together, so 1x plus 3x gives us a 4x. In the same manner on problem 2, we go ahead and complete it. So x times x is x squared again. The outer one is a 1x. The inner is a 2x. And the last term is a positive 2 and a positive 1, giving us a positive 2. The ones highlighted in yellow here are the inner and outer terms, which we can add together and get a 3x. On problem number 3, it starts involving some negative numbers. So we have x times x for x squared. Then on the outside we have x times negative 1, which gives us negative 1x. The 2 that are closest together, taking the sign with it, is minus 5 times x, so that's a minus 5x. And then the last term is negative 5. The last term here is negative 1. Negative times negative gives us a positive, so we have a positive 5. And then we combine the 2 like terms, so that gives us a minus 6x for the middle term in our answer. Problem number 4. We have x squared. We have on the outside a positive 1 times x for a 1x. The 2 that are closest together gives us a negative 5x. And the last term in the first expression is a minus 5. The last term in the second group is a positive 1, which gives us a negative 5. We combine the 2 that are in the yellow, the inner and the outer, and we get a negative 4x for the middle term in our answer. And then the last one finally is x squared for the first terms. Then the outside is x times negative 1 for negative 1x. The 2 that are closest together is a positive 5 and an x for 5x. And then the last term here is a positive 5. The last term in the second grouping is a negative 1 for a negative 5. Again, we combine the 2 terms that are alike, the outer and the inner, which gives us a positive 4x. We have some special cases that your textbooks list. I don't particularly like special cases unless you're going to be doing a whole lot of these kinds of problems. So there's no need to memorize these or use them unless you just want to. So where we have the special case of a plus b, the quantity squared, you can just write it as a plus b times a plus b. The special case of a minus b, the quantity squared, can be written as a minus b times a minus b. And then the third special case of a plus b times a minus b, rather than remembering what the formula is, you can just multiply those the long way, which we're going to do in a few minutes, or the FOIL method. Any of those ways are equally easy. So instead of using special case 1, we would write 4x plus 1, the quantity squared, as 4x plus 1 times 4x plus 1. We would use FOIL for the first 2 terms. 4x squared would be 4x times 4x would be 16x squared. The outside gives us a positive 4x. The 2 closest together gives us a positive 4x. The last term here is a 1. The last term over here is a 1, so we have a positive 1 for the last term. Then we can combine the 2 inside terms here together, the inside and the outside, giving us a positive 8x. For special case 2, where we have 4x minus 1, the quantity squared, we write 4x minus 1 times 4x minus 1. We can again use the long way or the FOIL, and we get 4x times 4x is 16x squared. The outside term gives us 4x times negative 1, which is negative 4x. The two that are closest together gives us another negative 4x. And then the last term here is negative 1 times another negative 1 gives us a positive 1. Then combining the outer and the inner terms, minus 4x gives us minus 8x. So that's how you can use just the regular FOIL method rather than having to memorize those special cases. The third way of multiplying is, I call it the long multiplication method. You can multiply using it just like you do just like you use long multiplication using numbers. You may stop here if you want to. You're not required to use this method. I know some students in the past have found it easier. So this is totally optional. You can use it if you want. It is not required. So FOIL and multiplying the long way give you exactly the same results. FOIL probably allows you to multiply more quickly after you've practiced it, and you can multiply things in your head more easily. But FOIL only works when you have two terms times two terms. The long way works for any number of terms. So what I'd like you to do is not use your calculator unless you want to check your answer, but multiply by hand 31 times 23. After you've done that and you check your answer, you should see your answer here. It should be 713. So what you did is when you put 31 on the top and 23 underneath, the 23 has 2 digits and the 31 has 2 digits. So you took the 3 times the 1 and got a 3. You took the 3 times the 3 and got a 9. And then what you did is you put a 0 here for a placeholder, or you may have left that 0 out altogether. And then you took 2 times the 1 for a 2 and the 2 times the 3 for a 6. So you essentially had 4 multiplications. 2 things times 2 things gives you 4 multiplications. Then what you did is you drew your line and you added. So 3 and 0 gives you 3, 3 plus 0 gives you 3, 9 plus 2 gives you 11, so you carry 1 and you get a 7. So you have the 4 multiplications where you took the 2 digits times 2 digits and you had 4 multiplications. In general, this is exactly how you're going to multiply 2 polynomials together. You're going to multiply each term of one polynomial by every term in the second polynomial, and then you're going to add those like terms together. So here we have an expression 2 things times 2 things. So we're going to expect to have 4 multiplications. So we take the negative 3 times the 2 for a negative 6, and the negative 3 times the x for a negative 3x. Then we moved over, just like we did in the long multiplication of numbers, and take x times 2 for a 2x, lining it up underneath the negative 3x, and x times x, we get x squared. We draw our line, and then we combine the terms that are alike, which are these inner and outer terms if we were using FOIL, and we get a minus 1x here. So our answer is x squared minus 1x minus 6. If I'd used that during the FOIL, it would have looked like this. It would have been x squared, the outside would have been negative 3x, the inside would have been 2x, and the last term would have been negative 6. You can see those exact same numbers up here where you did it the long multiplication way. So if you like the long multiplication way, go ahead and use it. If you don't want to use that and don't want to learn any method, it's not necessary that you go ahead and do that. The long multiplication also works for, we said, any number of terms. So here's an example where there are 3 terms times 3 terms. So I would expect to have 9 multiplications. So the first thing we're going to do is we're going to take this 3 here in the yellow, and we're going to multiply it by each of the terms on the top row. That's where I get the 6x squared plus 9x plus 3. Then I'm going to go to the plus 2x, and I'm going to multiply it by every term on the top row. So I get the second line down here, which is the 4x to the third plus 6x to the second plus the 2x. And when I write these down, I'm going to line them up with what they match up with above. And then lastly, I'm going to take this x squared, which is the third term here, and I'm going to multiply it by each one of the 3 terms on the top row, which gives me x to the fourth plus 3x to the third plus an x squared. Again, you could write a 1 here if you wanted to. Go ahead, draw your line, and combine the like terms together. and you'll end up with this. So the advantage of, rather than trying to multiply each term by each term and get these 9 multiplications, is that when you do it the long multiplication way, they're already lined up for you properly as you've gone through it. At this point I'm going to stop it, and if you want to, you can continue on the next video.